Unit 2. Energy. Lesson 1. Energy, resources and forms. Fuel and energy. Give reason for. The fuel inside the car is similar to the food inside the body of the living organism. This is because burning each of them produces energy, which makes the car move and the living organism do work. Work. If you want to move this piece of stone, you can't only order it to do this. You have to exert a force on it to force it to move in a certain direction, whether this force is a pushing force or a pulling force, by any means. So when a force acts on a body, it moves a distance in the direction of such force. It is said that a work is done on such object. Joule. It is the measuring unit of work. Also, it is the measuring unit of energy. The used mathematical relation to find work is equal to force times displacement, and its measuring unit is joule. If we want to find force is equal to work over displacement, and its measuring unit is Newton. For displacement, it is equal to work over force, and its measuring unit is meter. Problem. Calculate the work done by a person to lift a weight of 130 Newton, a distance of 10 meters height. Given, force is equal to 130 Newton, distance or displacement is equal to 10 meter. So we want to find work. Work is equal to force times displacement, which equals 130 times 10 equals 1300 joule. What's meant by energy? It is the ability to do work or to make a change. And its measuring unit, as we said before, is joule. What are the forms of energy? We have many forms of energies. We will only mention 7 of them. The first form of energy is mechanical energy, which is equal to potential energy plus kinetic energy. Examples for mechanical energy: stretched spring, waterfall. The second form of energy is light energy. Examples: electric lamp, kerosene lamp. The third form of energy is sound energy, which is produced from loudspeakers and radio cassette. The fourth form of energy is electric energy, which is generated from wind generators and solar cells. The fifth form of energy is chemical energy, which is stored inside food and car battery. The sixth form of energy is heat energy, which is produced from heater, oven, and burning of wood. The seventh and the last form of energy is nuclear energy, which is resulted from the reaction in the nucleus of an atom. Resources of energy. The main resource of energy is the sun, which is permanent source of energy. The wind, which is considered renewable source of energy. Food, which contains chemical energy, and we can get energy from it through chemical reactions, through respiration. The fuel, which we can get energy from it also through chemical reactions. And fuel is a non-renewable source of energy. This means that it will end in some day. The final resource of energy is waterfall, which is considered from renewable source of energy, which is used to generate electricity. Give reason 4. Developed countries aim to use the solar energy, wind energy, and the movement of water more than before. This is because they are cheap resources of energy and do not pollute the environment. The mechanical energy. What's meant by mechanical energy? It is the summation of potential and kinetic energies of the body. For example, if we have this worker and this worker is holding this small container and he will climb this ladder, as you can see, as its height from the ground increases, its potential energy increases. And if he let this container to fall, the kinetic energy of the container increases and its potential energy decreases. Let's do it with a larger container. As we go up, its potential energy increases, but in this case, it has a higher potential energy than the first one. If this worker let this container to fall down, its potential energy will decrease and its kinetic energy will increase. If we have a ball and this ball is left to fall down from a height of 2 meters, so its potential energy is maximum at that height. And its potential energy can be calculated from the rule mgh, mass times gravitational acceleration times height. So its potential energy is 20. As this ball falls down, its potential energy decreases and its kinetic energy increases. When this ball reaches the height of 1 meter, its potential energy decreased into 10 joule. And we will note that its kinetic energy will increase from 0 to 10 joule. But if we add them together, potential and kinetic energies, we get 20 joule, which is the mechanical energy. So at maximum height, mechanical energy equal potential energy only. On reaching the object at the ground, mechanical energy is equal to kinetic energy only. At the midpoint, mechanical energy equal twice the kinetic energy or twice the potential energy. This is because at midpoint, kinetic energy is equal to potential energy. And the work done in this case is equal to mechanical energy or is equal to potential energy plus kinetic energy. Problem. Calculate the mechanical energy of a moving body. Its potential energy is 2000 joules and its kinetic energy is 100 joules. Mechanical energy equals potential energy plus kinetic energy. Mechanical energy equals 2000 plus 100 equals 2100 joules. Potential energy. What's meant by potential energy? It is the stored energy in the object due to a work done on it. In this case, this person is doing a work to lift this stone, and as the height of this stone increases, its potential increases until it reaches the maximum potential energy at C. And if this person let this stone to fall down, its potential energy will decrease gradually and its kinetic energy increases until it reaches its maximum value just before hitting the ground. Factors affecting the potential energy. The first factor is weight of the object. If we have this stone, it has a mass, so it has weight, and it has a height from the ground. If we have two spheres, sphere A of a larger weight and sphere B of a smaller weight, and they have the same height, and these poles are left to fall down, we will see that the depression produced from metallic sphere A is larger than that produced from B. This means that potential energy increases as the weight of the object increases. So the potential energy stored in an object increases by increasing its weight. And to calculate the weight, we have to multiply mass times gravitational acceleration, or g, where g is a constant which is equal to 9.8 or approximately 10 meters per second squared. The second factor that affects the potential energy is height of the object from the ground. The potential energy increases by increasing the height at which the object reaches. For example, if we have two identical spheres, A and B, and they are left to fall from different heights, the higher ball will produce a larger depression than ball B. So, by increasing the height, the potential energy of the object increases. Note the following. To calculate potential energy, we use the following relation. Potential energy equals weight times height. So potential energy of an object is directly proportional to its weight and the height from the ground. This means that by increasing the weight or height, the potential energy also increases, or vice versa. Potential energy equals weight times height, and its measuring unit is joule. Weight equals potential energy divided height, and its measuring unit is Newton. Height equals potential energy over weight, and its measuring unit is meter. Weight equals mass times gravitational acceleration, and its measuring is Newton. Potential energy equals weight times height, and we can replace weight by mass times g. So potential energy equals mass times g times height, mass times gravitational acceleration times height. Problem. An object, its mass is 5 kg and it is at a height of 8 meters. Calculate its potential energy if its height decreased by 2 meters. Calculate its new potential energy. Given mass of this object is 5 kg, the first height is 8 meters, potential energy is unknown, the second height is 6 meters. This is because the height is decreased by 2. So 8 minus 2 equals 6 meters. To calculate potential energy, we have to multiply weight times height. But first we have to find weight. Weight equals mass times gravitational acceleration equals 5 times 10 equals 50 Newton. Now we can calculate potential energy at height of 8 meters equal 50 times 8 equals 400 joule. Potential energy at 6 meters equal weight times height equals 50 times 6 meters equal 300 joule. Kinetic energy. What's meant by kinetic energy? It is the work done during the motion of an object. What are the factors affecting the kinetic energy? Velocity of the object. Kinetic energy of a moving object increases by increasing the speed or velocity of motion. Note the following. Kinetic energy equals half times mass times velocity squared. This means that kinetic energy of a moving object is directly proportional to its mass and its speed or velocity. To calculate kinetic energy, we have multiply half times mass times velocity squared, and the measuring unit of kinetic energy is joule. Mass equals kinetic energy over half times velocity squared, or 2 times kinetic energy over velocity squared. And the measuring unit of mass is kilogram. To calculate velocity, we have to take the square root for kinetic energy over half times mass, or the square root for 2 times kinetic energy over mass. And the measuring unit of velocity is meter per second. Problem number 1. A racing bike is moving with a velocity of 50 meters per second. Calculate its kinetic energy by knowing that the mass of the bike is 4 kg. Given velocity equal 50 meters per second, mass equal 4 kg, kinetic energy is unknown. Kinetic energy equal half times mass times velocity power 2 equals half times mass equals 4 times velocity equals 50 power 2 equals 5000 joule. The second problem, a stone of 0.8 kg was thrown up, and when it reaches 10 meters, its velocity was 8 meters per second. Calculate its potential energy, kinetic energy, and the work done on it. Given velocity equal 8 meters per second, mass equal 0.8 kg, height equal 10 meters, kinetic energy is unknown. Weight equal mass times gravitational acceleration equal 0.8 times 10 equal 8 Newton. Potential energy equal weight times height equals 8 times 10 equals 80 joule. Kinetic energy equal half mv squared equal half times 0.8 times 8 squared equal 25.6 joule. To find work in this case equals mechanical energy equal potential energy plus kinetic energy equal 80 plus 25.6 equals 105.6 joule. Problem number 3. The opposite figure represents the falling of a ball of weight 10 Newton from the position A to the position C passing through B. Calculate kinetic energy at A and potential energy at B. First, we have to write down given weight equal 10 Newton, height equal 1 meter. Kinetic energy equals 0. Potential energy at B, weight times height. The height of B from the ground is 1 meter. So 10 times 1 equal 10 joule. Let's compare between potential and kinetic energy. The first point of comparison is definition. What's meant by potential energy? It is the energy stored in the body due to a work done on it. Kinetic energy, it is the work done during the motion of an object. Factors affecting potential energy: weight and height. Factors affecting kinetic energy: mass and velocity. Examples for potential energy: Water at the top of waterfalls has potential energy. Examples for kinetic energy: the running water has kinetic energy. Law used to calculate potential energy: potential energy equal weight times height. Law used to calculate kinetic energy: kinetic energy equal half mv squared. What is the relation between potential and kinetic energy? Potential energy equal mechanical energy minus kinetic energy. Kinetic energy equals mechanical energy minus potential energy. Note the following. If we have a pendulum, as you can see, it has the maximum potential energy at the highest point. As its height decreases, its potential energy decreases and its kinetic energy increases. And kinetic energy will be maximum when its speed is maximum, just before hitting the ground, or at the original position of pendulum. On the ground, potential energy equals 0 and kinetic energy is maximum. By increasing the height again, its potential energy increases and its kinetic energy decreases until it becomes 0 at maximum height. At maximum height, there is no kinetic energy and potential energy is maximum. On the ground, or just before hitting the ground, kinetic energy is maximum and there is no potential energy. Kinetic energy equals 0 at the maximum height. This is the end of lesson 1. Thanks for watching.